Hi everyone. Today we will be explaining the metabolic pathway for trimethylaminuria, the fish malodor syndrome. This disorder is characterized by a fish-like body odor.
Trimethylaminuria is a metabolic disorder that results in an abnormal amount of trimethylamine in the urine, sweat, expired air, and other bodily secretions.
This occurs as a result of dysfunctional flavin-containing monooxygenase 3, or FMO3, which is the enzyme that normally converts trimethylamine to trimethylamine N oxide.
If FMO3 fails to convert fish-smelling trimethylamine to odorless trimethylamine N oxide, the high quantities of trimethylamine will be released in bodily fluids, hence causing the affected individual to smell like fish.
So let's take a look at the pathway.
The pathway begins with a diet, particularly foods such as eggs, legumes, organ meats, and saltwater fish, as they contain high quantities of choline, carnitine, lectin, and TMAO.
During the digestion process, these molecules are broken down by gut bacteria and converted to TMA, which is the source of the odor.
To treat some diseases such as Huntington's chorea and Alzheimer's, some patients may receive choline as a therapeutic oral supplement, which may also lead to an excess of TMA and exacerbate this disease.
Once produced, TMA is able to diffuse into the liver. It is here that the FMO3 enzyme normally acts to convert TMA to TMAO, an odorless molecule.
However, in the case of trimethylaminuria, there is a genetic mutation that results in dysfunctional FMO3, so TMA cannot be converted to TMAO.
Therefore, fish-smelling TMA is released in bodily fluids, such as sweat, urine, and expired air.
Taking a closer look at the conversion of TMA to TMAO, we see the chemical reaction shown here.
The cofactor NADPH binds to the oxidized state of the FAD prosthetic group, reducing it to FADH2. Then, oxygen binds to the formed NADP plus FADH2 enzyme complex and reduces it, resulting in a 4A hydroperoxyflavin. This 4A HPF is stabilized by NADP plus in the catalytic site of the enzyme.
In the presence of a substrate, in our case TMA, a nucleophilic attack occurs on the O atom of the prosthetic group. The substrate is oxygenated to form TMAO and 4A hydroxyflavin.
The flavin product then breaks down with the release of water to reform FAD, to recycle FAD back into the cycle. Because of the low dissociation constant of NADP plus enzyme complex, NADP plus is released at the end of the cycle and the enzyme returns to its original state. The rate-limiting step involves the breakdown of FADOH to water and the release of NADP plus.
The net equation of the oxidizing reaction of TMA to TMAO is shown here.
Those with trimethylaminuria have a mutant form of the FMO3 enzyme. This mutant form isn't able to perform the redox reaction, so TMA can't be converted to TMAO. This results in the buildup of FMO3 substrate, TMA, which causes the fishy odor.